Hello, my name is Benjamin T Stanley. I am a local chef of Chicago. My day job, I am a research and development chef for a small flavoring company called Bell Flavors and Fragrances. It's based up in Northbrook. But when I come home at night, I like to experiment. I like to do a lot of fun things. I like to kind of teach myself a lot of different things. So I'm basically going to do a rundown on fermentation and my personal experiences with it, working with it, kind of learning how to do things myself, and making different fermented products. And fermented foods is just, it's one of those products that a lot of people don't really understand the process for, but they love them. Over, I think it's 1/3 of the food we consume is fermented. That could be anything from soy sauce, tea, chocolate, coffee, sauerkraut, kimchi, any kind of cheese. We consume over 15 million tons of cheese annually as a culture. Over 22 million gallons of beer and other fermented liquors like wine, any kind of vodka, stuff like that. And the basic understanding of why these things happen is generally unknown to the public. By definition, fermentation is an anaerobic process. So basically, it's the conversion of sugar or some kind of carbohydrate plus some kind of bacteria, and it converts it into alcohol or combined with energy, along with other enzymes, other various chemicals. In a food sense, it doesn't have to be anaerobic. It can also be aerobic. So in large processing situations, we'll add air, we'll add different temperatures, we'll kind of control the conditions of the way things ferment to help kind of facilitate that fermentation, to help the growth of organisms, to help them thrive, to help them feed. So this is the chemical reaction. It looks pretty difficult, it looks kind of weird. Basically, sugar, any kind of sugar, glucose, fructose, sucrose, you add it to your microbial agent like yeasts, molds, other kind of bacteria, and they release alcohol, which is basic ethanol, carbon dioxide, and some kind of energy unit, whether it be heat, whether it be some kind of different byproduct, CO2, stuff like that. Why this is an important process? Fermentation is probably one of the oldest methods of preservation. There's quite a few different methods that are tried and true. The first one is salting. What salt does is it basically draws the moisture out of your product, and it also inhibits microbial growth. So it helps inhibit different organisms from growing, stuff like that. But it's usually the fungicidal spores, stuff like that, that it helps prevent. So what you're doing is the salt will pull the moisture out, pull out that water, which is a breeding ground for a lot of different organisms, stuff like that, and then it will create this boundary between your product and the air, so that different organisms can't penetrate through that salt solution. Another one is smoking. Same idea. The smoke is antimicrobial. You're basically enveloping a product in smoke. You're creating this kind of crust that goes over your product, and it's helping keep the air from getting into your product. It's helping keep those organisms from fermenting your product. And then the other one is drying or dehydrating. Again, you're pulling the moisture out. That moisture is what helps facilitate this growth. Fermentation has evolved in a lot of other processes, kind of like ethanol preservation, where the use of alcohol is used to inhibit growth. The high levels of alcohol will kill organisms, as well as lactic acid preservation, which is what you see in cheese. The high acid levels, same with vinegar, pickling. The high acid levels will only permit certain organisms to grow, but not others. When we're fermenting products, there's two different kinds of techniques we use to get the process going, to get it kind of started, facilitated, inoculated, as you might say. The first one is wild fermentation, which is basically just leaving a product out, exposing it to air, exposing it to anything that's flying around the room. A lot of yeasts are present in everyday flours, on the outsides of fruits and vegetables, on the outer peel, anything that's really high in sugar, it will attract some kind of organism to come and feed on it. The other way is to have human input. Basically, human input provides a more controlled environment that we can change and affect the final outcome of our product. So what they'll do is they'll actually develop a certain product, let's say yogurt. You know, they have this yogurt that they've tried and true, they like the way it tastes. What they can do is take their original base that they started out with, heat it to kill all the organisms that are in there, and then reintroduce the yogurt that has the flavor and the consistency that they want to that heated base. And that basically starts out with a clean palate and then only incorporates the organisms that they wanted. And then they do the same method for making the yogurt, and it will come out, for the most part, the exact same way as the original one, if they do follow the same process. The wild fermentation is a little bit more unreliable. There's a lot of different things in the air that can contribute to it, but that also will develop the most interesting flavors. Stuff like sourdough breads. If you make a sourdough bread in San Francisco, it will taste completely different than a sourdough bread in Chicago because of the temperature, the environment, the different yeasts that are in the air, stuff like that. Other factors in the end product, you have temperature, environment, the season, humidity, your experimentation, basically what your entire process is and your flow, how things get done. This chart over here just kind of goes through a little bit of each one. In winemaking, clarification, if you take out some of the solids in your product, it will affect the final fermentation of the product. You'll have less tannins, less yeast, because the yeast kind of stay on the sides of the grapes. So if you pull those skins out, you're actually pulling out some of the actual organisms that are doing the fermentation. Temperature shock, whether that organism has the right temperature to grow. Usually about body temperature is the perfect temperature for the organisms to thrive. If you make it go really cold, it won't kill them, but they'll kind of go to sleep. They kind of won't do anything. They'll get lazy. They won't actually ferment anything. If you raise it up too high, you'll kill them, and then they can't do anything. Other minerals, other things that can help facilitate the growth, whether it be oxygen, different minerals, different kinds of salt, some kind of phosphate or nitrite, and as well as the microbiological environment, whether they're yeasts and molds and everything are in the surrounding area, whether what you're trying to inoculate with is able to compete with what's already in the air. Traces in history, like I said, this is one of the oldest processes for preserving foods, and it starts almost as old as 12,000 years ago. Mead was one of the first products that originated, and it's basically just a fermented honey drink. Honey collecting as early as 12,000 years ago in areas of like Egypt and the Sumerian areas. And for most part, a lot of these things were discovered by accident. Honey, for example, is high in sugar, so it is an attractant for these yeasts and molds and other things. They would collect the honey, they'd mix it with water to make a drink, and they didn't have refrigeration, so they just let it sit out. Well, as it sat out, they started to notice, little things, changes going on to it. They started to notice bubbles come up. They started to see discoloration, different things growing on it. And this visual cue is originally how fermentation happened. Just seeing the product change and tasting it as it changed to kind of, see the differences and see whether they liked it or not. Soy sauce dates back to over 2,500 years ago. Until the 17th century, with the creation of the microscope, it was generally unknown why these things happened. People just started doing it in their homes, in their basements, and they found that it tasted good, and they just went off of that. They started making cheeses, they started making alcohols. They didn't really understand why. When the microscope was created, they started to notice these little organisms, different things inside of the foods. Well, it's science in the time. It was such a new concept that it was generally disregarded. A lot of scientists kind of refused the fact that this could even happen, that there was some kind of small living organism in the things that they're meeting, and they just didn't even believe in it. They completely rejected it outright. It wasn't even until about the 19th or 20th century when Louis Pasteur actually started to make this connection between what was growing and the changes that were done. The way that he came upon this process was that a company that was making a beet juice alcohol was having a lot of variations in his product, and he didn't understand why. He had been making it the same way for a number of years, and it was just coming out different every single time he was making it. It was very unreliable, it was affecting his business. So he gave it to the chemist, Louis Pasteur, to test out. Well, upon looking at the microscope, he noticed that from older samples of the alcohol versus newer ones, there were different things, different organisms, different small bacteria that were present. So he actually came up with the method of pasteurization, which we all know is just heating a product that killed that microflora. And then he reintroduced it with the specific starter that he wanted. Some benefits of fermentation, preservation. It preserves not only the product itself, but it also preserves nutrients. It will actually increase the way that the body can kind of use some of the nutrients, especially like vitamin B, vitamin C, calcium. It prevents them from being destroyed by sitting for a long period of time. It kind of prevents the degradation of the product itself. The digestive aid. A lot of the products, if they're not heated, they still have these live cultures in it. It still has this microflora. And because this microflora can survive in very acidic environments, it still is highly active in your intestinal tract, in your body system. So it actually go through your system and often kind of make a small home in your intestinal tract that will actually help you digest foods. It will help you absorb nutrients better. It will help absorb different nutrients that your body normally can't break down. A lot of proteins, a lot of amino acids that your body has a really hard time breaking down. These organisms will do the work for you. Flavor development. There's a specific chemical reaction that happens when you're doing this fermentation, and you're developing a lot of different flavors through the use of enzymes, through the use of creating acids and alcohols. It has antioxidant properties. It actually opens up the antioxidants so that your body can use them a little bit better. It's a fortifier. Like I said, it creates vitamin B. It removes toxins. The process of fermentation is used for ingredients like coffee. When coffee's grown, it has a cherry on the outside of it. When they pick the cherry, they let it sit out so that that fruit can ripen, kind of fall off, and then they take the beans from. And that helps remove some of the toxins that are associated with the cherry. The same is true with like certain types of cassava. In Africa, they have to take cassava and soaking it in water to help pull the cyanide that is present in the vegetable out. Once they soak it in water, these toxins come out and they can actually cook the cassava and eat it. Again, yeah, it's a processing aid. Tea is another example. When they pull the leaves, they let them sit out to dry and ferment. This allows the tea to develop more flavor, have less moisture in it, last longer. And now I'm going to go over some specific examples. Vegetable ferments. They're basically usually using a salt brine to help protect the vegetables from rotting. Salt will pull the moisture out of the vegetable and actually create its own shell for the vegetable. Multiple changes occur in one thing. I use the example of sauerkraut. When you first start a sauerkraut, you add salt to your cabbage. The salt will pull the moisture out. It will create this barrier for your sauerkraut. And then it will only allow certain organisms to grow. When you're using just straight water and salt, only the coliform can grow. Now once the coliform grows, it proliferates, it feeds, it will start taking the carbohydrates from the cabbage, and it will output a certain level of acid. But once the acid starts to get too high, it actually diminishes the amount of coliform that's in the system, and then the leuconostoc will come in and start feeding on that acid. Again, it goes up, it proliferates, then it starts to die down, and finally lactobacillus, which is one of the most common, comes in and it will start to create lactic acid, which is that sharp, kind of cheesy sensation that you get from a lot of products like cheese, sauerkraut, kimchi. Now this is a very traditional crock for making sauerkraut. Basically what you do is you take your salted cabbage, which can be, sauerkraut can be anything. Any kind of vegetable can be made into sauerkraut. You take your vegetable, you mix it with salt, spices, I use onions, apples, bay leaves, peppercorn, stuff like that. You mix it with the salt, and then what you're going to do is you're going to take a very, very heavy weight and push it on top of those vegetables. What the weight does is it helps push the moisture out of the vegetables and leave it at the bottom. You want this to be an anaerobic environment so that air doesn't affect how everything ferments. You don't want the molds, you want the actual sauerkraut to develop an anaerobic environment. So once you weight it, what you're going to do is you put a little bit of salt water around the rim of the crock. And what the salt water does is it, again, helps keep the microbes from entering into your crock, and you put a lid on it. And you let it sit for anywhere from 1 week to up to a year. You can let it sit unrefrigerated. You want to leave it at ideal temperature for growth, which is anywhere between 85 and 100 degrees. And it's kind of dark, you can't really see it, but this is an example of the sauerkraut that I made today that you guys are going to be trying. It's basically just white cabbage, it's got some onions, some apples, some different spices, stuff like that. This is, I put it in the bowl, added salt to it. You generally add about a 5 to 10% solution of salt to your sauerkraut, and the salt will determine how long it sits for. If you add more salt, then you will take your sauerkraut and you'll age it for a longer amount of time at a lower temperature. If you add less salt, then you're going to age it for a shorter amount of time at a higher temperature. Kimchi is one of the most popular condiments of Korea. It's said that every Korean on an individual basis consumes about a quarter pound of kimchi a day, which really adds up by the end of the year. It's a very, very artisanal product. It's made by almost every family for the family. It's not really something that you go out and buy as often. That is traditionally. Nowadays, with convenience and stuff like that, you can get it mass-produced. But usually it was something that was a very home-orientated part of the culture. They'd come home, they'd harvest their own vegetables, they'd make the kimchi out of whatever vegetables they had available. They'd mix it with salt, spices, generally chili pepper is used. They'll use seafood, they'll use anything. The big difference between kimchi and sauerkraut is that when you make kimchi, you soak your vegetables ahead of time in salt water. What this does is it pulls the moisture out, infuses salt into the vegetables, and then it also kind of helps give a crisp texture to that kimchi. So this is soaking some cabbage to make into the kimchi. Again, this is about a 5% salt solution. Once you're done soaking it, you pull it out, chop it, mix it with various vegetables. I used radish, carrot, a couple of different kinds of greens. You generally use ginger, garlic, red pepper. And then you're going to take it and put it in, it's very similar to the sauerkraut crock, but you can do it at home with just about any kind of container. Usually you want to use some kind of hard plastic. You don't want to use metal because the metal will actually react with the acids and kind of create a tinny taste to your food. So any kind of plastic, any kind of food grade, usually the big white buckets that you find, as long as it's never been used, is a good option. And then what you're going to do is you're going to put a weight on top to bring that moisture level up to help protect your vegetables. This is an example of a fruit kimchi made in the exact same style. Again, you take your fruits, cut them up, salt them. You can soak them in brine if you want, but it's not necessary. And then you're going to take them and weight them down. Bean ferments, a lot of people are familiar with soy sauce, miso, tempeh, lesser so natto, which is a Japanese bean fermented with whole soybeans. Because of their protein content, they're very difficult for the human body to digest. So we use the process of fermentation to help break down these proteins so that they're easily digested by the human body. This is a kind of a simple diagram of how soy sauce is made. Basically, you take your ingredients of soybean, wheat, and some kind of mold that's already been established from a different process. Usually the same molds that they use for making rice wine, sake, is also what's present in soy sauce. What they'll do is they'll put it in an open air container, let it proliferate, kind of grow, and then after they do that, they'll take it, put it in a container, let it sit at a specific time and temperature for about 6 months. After it's sit for a couple of months, they'll take it, they'll press it to get all the liquid out, strain it, and that's how you have soy sauce. That's a naturally fermented soy sauce. They also have a method which is chemically induced that much quicker, usually takes about a couple hours, but they'll take soybeans and they'll add hydrochloric acid to it. This hydrolyzes the vegetables, and then it creates that kind of meaty taste to it. You'll notice that that tastes very chemically, it doesn't taste as sweet. There's a lot of flavors that kind of just don't exist when you have this chemically produced soy sauce. Tempeh is one of the more interesting products. Yes?
Do you have any idea if like the Kikkoman or whatever the soy sauce everybody has in the store, is that the kind of...
Kikkoman is actually one of the few that are naturally brewed.
Okay.
A lot of the stuff you buy in the store is naturally brewed. A lot of the stuff that's in more industrial scale, stuff that you buy, processing, stuff like that, is not.
Okay.
Tempeh is another bean ferment, which is basically cooked soybeans that are allowed to cool. They have a starter added to it, and then they sit in an open air environment. What happens is then the starter will proliferate with the addition of air and warmth, and it will start to spread, and it will create this kind of mold. What the mold will do is it will actually take all these soybeans and connect them. The mold will grow across the entire thing of tempeh and actually pull it together to be this firm brick. And it actually will develop very earthy and kind of mushroom currents to it that are often desirable in the vegetarian community because it has that texture to it. It can absorb a lot of flavor, and it has that kind of meaty texture to it. Dairy ferments, lactobacilli, which is the common bacteria that are in dairy ferments, they eat the lactose present in the dairy, and they turn it into lactic acid. Lactose is basically a ingredient that's in most dairy that a lot of humans have a hard time digesting because we do not have the enzyme that breaks down this lactose. So that's why if you're lactose intolerant, a lot of people that are lactose intolerant will find that if they eat an aged cheese or if they eat a yogurt that's heavily fermented, it doesn't bother them as much. That's because the fermentation, the lactobacilli are actually taking those enzymes that you can't process and doing it for you. Some examples: buttermilk, yogurt, butter, all sorts of cheeses, kefir, which is another fermented yogurt product. Yogurt, more so now than previously, is starting to be promoted with having probiotics. It's having these organisms in it that are helping your digestive tract, they're helping you process your food, they're helping you speed up your metabolism. This is not a new concept. This has been around for thousands of years, and it actually went away with the invention of pasteurization because people were afraid of these things that were in their food, and they were afraid that they were going to make them sick. If you take yogurt and you just make it normally, it will naturally have these probiotics. It will have these digestive aids in it. So when you actually pasteurize it, you're killing all those things. Or what they'll do is they'll add the starter to it, allow it to turn into yogurt, heat it after it's turned into yogurt to kill everything, to make it more safe for human consumption. As you know, safe as in maybe not exactly safer, but more well received by the public. When you're making yogurt, you only need to add a little bit of the starter to get it started. If you add too much, it will actually crowd everything, and it will cause less of the bacteria to grow, but more of the acid to be made. So you'll have a very, very sour, astringent yogurt. It's a relatively quick product to make. It only takes about 8 to 12 hours. Depending on how long you sit at the temperature where the bacteria proliferate at, it will affect how sour your product is. So generally what you do is you heat your yogurt up, you This is me heating the yogurt up. Heat it up to about 180 degrees first. Heat your milk. Sorry, you start out with a milk base. You can choose how much fat is in your milk base at the beginning. A thinner yogurt will have less fat. A very thick yogurt will be high in fat. You can go up to about 40% fat and still have correct fermentation of yogurt. I began by heating up the product to 180 degrees. This isn't necessary. What this does is it helps create a thicker yogurt. It helps kind of loosen up the structure of the proteins so that when bacteria come, it will help tighten them up a little bit better. This is the yogurt after it's finished. So after you heat it up to 180 degrees, you're going to cool it down to about 100 to 110, which is the ideal temperature to make yogurt at. You're going to add your starter, and then you're just going to try to leave it at that temperature for a long period of time. Like I said, 8 to 12 hours, up to 24. The longer you leave it, the more sour your product will be. So if you want a less sour product, leave it for 8 hours. If you want a more sour product, leave it for 20 hours. What will happen is the enzymes will break down, it will start to sour the product, it will make lactic acid, and then it will actually thicken the yogurt itself. Cheese is a little bit different because you don't actually need the fermentation product to make the cheese initially. You need the fermentation product to help ripen the cheese afterwards. So what we're doing is we're adding acid to some kind of milk base and heating it to a certain temperature. And that will actually cause the milk to separate into curds and whey. The whey is the liquid, the curds are the solids. You can also use rennet, which is an enzyme that's apparent in a lot of animal stomachs, a lot of linings of different animals. And then what you'll do is you'll strain the whey off, you'll leave the solids, and then you'll just let them sit. And that's how you'll get the fermentation product in your cheese. You can add different strains of bacteria to get different kinds of cheeses. And that's why there's so many different cheeses on the market, because depending on the area they're from, depending on what's in the environment, that's where the flavor's coming from. Blue cheeses is one of the most notorious. It's a very, very rapidly growing organism. It spreads very quickly. So if you're in an environment that made blue cheese, you most likely will have everything else in that environment turn into blue cheese or have that same mold on it within a couple of days because it's that rapid and takes over for that many other bacteria. Grain ferments, also very popular. I'm going to talk about sourdough breads. What happens is when you add the addition of water to grains, you're helping activate the yeast that are already naturally on the grains, and you're helping break down those grains to help your body process them a little bit better. The addition of water will cause the yeast to activate. It will actually start to eat the carbohydrates of the grain themselves and help loosen them and then convert them into a more digestible product. These yeasts are found pretty much everywhere. Anything high in sugar. If you've ever looked at some kind of plum or grape, that white film on the outside of your fruit is actually yeasts that are feeding on the sugars of the fruit itself. So this is how you start a basic sourdough bread. All you really do is just take flour and water and put them together. Put a cover over it, let it sit. What I did for mine is I actually used potato water. I cooked some potatoes. After I cooked the potatoes, I saved the water and I turned that into a sourdough bread. That extra starch from the potatoes just gives something extra for the yeast to feed on. So what you'll do is you'll mix those two products together, let it sit at the ideal temperature, again 80 to about 110 degrees, in an open air container. You want to leave it open air at the beginning because this is where the yeast are going to come from. They're going to come from the air. You can add baker's yeast if you want, but that kind of defeats the purpose of having this sourdough that's made with the things that are naturally occurring in the environment. You let that sit overnight at the ideal temperature. The next day you come back to it, you remove half of it, and then add the same amount of flour and water that you removed. And this introduces, again, newer yeasts, helps add some more carbohydrates so that the yeast can feed off of and start to proliferate more. And you do this for about 3 to 4 days until you start to see it bubble. Once it bubbles, then you have a solid starter. That bubbling means that the yeast are active. They're creating lactic acid, which is where that sourness is going to come from. And it means that they're going to continue to be active as long as they keep getting fed. As long as you keep the vital nutrients of heat and sugar for them, they'll keep going. So these starters can pretty much be kept indefinitely. Some of the sourdoughs from San Francisco are over 100 years old because they started a sourdough 100 years ago. They take out half of it, make bread, add more flour and water, and then they just keep making it every day using that same starter. And it over time develops a lot of different flavors from a lot of different organisms. This is another fermentation practice, which if you've watched my Twitter, this is one of the first things that I've kind of experimented with, which was fermented oatmeal. You take any kind of oats, soak them in water overnight, and the yeast present in the oatmeal will actually kind of break down the starch, and it will result in a very, very kind of creamy, gelatinous oatmeal. Fruit ferments, we see this with wine, we see this with different kinds of root beers, we see this with, I guess it would be grain, but we see this with normal beer as well, but the addition of fruit is normal in making normal beers. What you're doing is basically, again, taking those naturally occurring yeasts in the air, and they're feeding off the sugar to the fruit. Specific sugars will kind of help change the final fermentation and that final flavor. So if you're using honey, if you're using molasses, if you're using sorghum, if you're using brown sugar, each one of these sugars has a different flavor profile, and different types of organisms will be attracted to, let's say, honey than brown sugar. That's pretty much it. I have a bunch of products here that we're all going to taste. I have a fruit kimchi that's made with pineapple, grapes, cilantro, ginger, some other spices. Again, let it sit for a week. I have a normal kimchi that's made in a very traditional style. It just has radish, some greens, chili pepper, garlic, ginger. I have a homemade sauerkraut that has the addition of apples and onions to it. I have some yogurts. I have a full fat yogurt that's made with a 40% fat. Kind of comes out to the consistency of sour cream. I also have a normal fat, like a 5% fat yogurt. And I also have some butter that was made with the yogurt. And we can talk about that process if you like. And I also have some, it's a ginger beer recipe, but I made it with galangal. Basically, took ginger, shredded it up, mixed it with sugar and water to have that environment so that yeast can grow. Once it started to grow, you add that to a base of ginger and sugar. Once you cool down that base, you add the starter that you made with the active cultures, and then you put it in an anaerobic environment by putting it into a bottle and letting it sit. And this will start to create, it will eat the sugars, it will create alcohol and CO2, and that's where the carbonation comes from, because you're concentrating that CO2 into the bottle, and so it can't escape, so it's infusing itself into the water to create carbonation. So yeah, if you guys want to come up and come taste some stuff, that's pretty much it for the fermentation talk. If you guys have any questions, we have to answer.